So the last thing that we're going to take a look at in regards to arithmetic sequences is how to go from one form to the other. So we're going to start off with recursive to explicit. Okay, so to go to explicit, what do I need to know? I need to know the first terms. That's easy because that's right there. So that's going to be 1. Okay, then I need to know the common difference. Now, how do I find the common difference? You just have to be able to identify that in recursive, the common difference is that after the previous term. So it's the previous term minus the common difference, or the previous term plus the common difference. See right there. So you need to recognize that this is the common difference. So you now know that D is equal to -10. Now that I know that, I can keep writing my explicit formula. So it says plus D, which is -10. So again, you're not going to do plus and minus. So you're just going to say 10. And then it is n minus 1. So once again, to go from recursive to explicit, it's very simple. You just need to be told what the first term is so you can put it in the equation. And then you need to be able to look at this recursive written format and know that the -10 right here is the common difference. Once you know that, you can write it into explicit. If you're asked to go from explicit into function notation, there's only one more step. Okay, so if this is from explicit into function notation, what you're going to do is you're going to distribute into the parentheses. So -10 times n. So I'm going to write this out right here. So I'm going to start off with 1. -10 times n is -10n. All right, and then the final step is also to distribute the -10 in here again. So I have -10 times -1, which is +10. All right, so now I'm going to combine like terms. So I've got 1 plus 10, which is 11, and then I just have -10n. But this, they want it in function notation in terms of x, so I'm going to change the n into x. So this is going to be -10x, and then 1 plus 10, which is 11, +11. All right, so this is it in function notation now. So that's how you go from recursive to explicit, and then from explicit to function notation. I'm going to check it with my formula to make sure that it's the same thing. So if I put in the function 11 minus 10x, okay, and I make it a table, remember my sequence starts at 1, right? So 1, I have 1, 2, I have -9, and if I press enter, 3, I have -19. Only difference between them is if you're going from function notation, it's the y-intercept is going to be 11. You can see the y-intercept is that, and my slope is going to be, and we are going to use this linear regression, my slope is going to be -10, okay, which is my common difference. So I just want to write those down. So slope is equal to D, and then A1 is going to be when n equals 1, whereas the y-intercept is going to be when x equals 0. So if you want to go from function notation to explicit, you want to know that, okay, I'm going to go look at my 0 term, which is 11. That is not my first term. That's what this is saying. All right, so if I'm writing function notation, I'm going to write y-intercept. But if I'm writing in a sub n, I know my first term is 1, not 11. So if I'm given function notation and asked to go into these two, I just need to find what my A1 is and my common difference so I can write it. So I know my common difference is exactly the same as my slope, but my first term is not where x is equal to 0, my y-intercept, but my first term is 1. You're going to actually do just the top of page 18. So here's some figures. Go ahead and write out the pattern. Okay, so figure 1 has how many hexagons and so forth. Fill this out. Okay, then write the recursive. Now that you know the recursive, find the 15th term like we found the 10th term here. Then write your explicit. Okay, so go from recursive to explicit like we did here. Went from recursive to explicit. And then go to function notation. So after you find the explicit, how do I then turn it into function notation, which is distribute? Once you know that, please tell me for arithmetic and linear where it starts at. What is the difference between the two? Now, arithmetic, we've done this in prior videos. I want you to know is discrete because it is a pattern. Right? It's a physical pattern that you can't have. We've talked about it in a previous video. I can't have figure 1.5 here because this is what it is. It exists as a hexagon. It's not half an hexagon. Whereas linear, I can have, it's not necessarily a real life situation. I can't have it to where it has decimals, so therefore it can be continuous. Then go ahead and graph it, and then tell me the domain and range. And please do remember, because this is arithmetic, it must be discrete.
Let's practice.